Evening Bearcats. Wow, it feels like forever since I've been with you on video. We're going to start our 4.5 graphs tonight of sine and cosine, and then tomorrow I'll have a second video that'll finish up sine and cosine, and then on Wednesday evening I'll have one on cosecant, secant, tan, and cotan. Alright, so tonight we're going to start with the equations of these graphs, and we're going to start with y equals a, and I'll tell you what all this means in a minute, and it could be a sine or a cosine graph, okay, depending on which trig function we're wanting. And one of the forms is bx plus or minus, and the reason I say plus or minus, it could either be plus c or minus c, not plus and minus together. And I'm going to use plus or minus again, meaning it could be positive d or minus d. I'm going to adjust this equation for just a minute. I'm going to factor out a b, and this following equation, or the adjusted equation, is the one that we would use. But sometimes you may see the equation given in this form, and you would want to factor out the b so that you can use our basic transformations that we're already familiar with. So I'm going to write the word or out here, but this would be the one that I would use the most often, this form. So I would say a equals a. And again, it could be sine or cosine. Also, please understanding a could be positive or negative. If it was negative, of course, it will be a reflection. We'll talk about that in a minute. And then I would factor out the b. So when I take out the b, inside would be x, because b times x would be bx, plus or minus, and it would end up being c over b. And then I'm going to close the bracket, and again it's plus or minus d. The plus or minuses here just mean it could be a positive, you could be adding or subtracting c over b, or you could be adding or subtracting d. Let's look at the basic shape of the graph using our prior knowledge. You want to pause this for a minute and write these two equations down, and make sure that you are highlighting or circling this equation. We're going to go back to it in a minute and identify each of the parts of this equation. But before we do that, I just want us to look at what the basic curves look like and how we would find those. I want you to go back and think about our unit circle for a minute. We think about our unit circle, we have 0 radians, of course we have pi over 2 radians, we have pi radians, 3 pi over 2, and back to 2 pi. And then we would know that would just continue, and we would keep adding pi over 2 each time. So this would be 3 pi over here, and then we would end up back over here again at 4 pi. All right, we could keep doing that. We also know there's some basic values for sine and cosine related to this, and those are ordered pairs. If it's a unit circle at 0, we're at 1, 0, and this would be our cosine. So in a minute when we graph, cosine will be associated with the 1 and sine would be associated with 0 at 0 radians or 2 pi. We know here at the top we would be at 0, 1, again cosine and sine. So at pi over 2, sine is 1. At pi over 2, cosine is 0. So it'll depend on which graph we're talking about in a minute. On this side we're negative 1, 0, and down here at the bottom we're 0, negative 1. And then of course we're back here at 2 pi. So I know you're familiar with all this, but I want to show you how this relates back to our graph. So let's make a table for our graph of our parent function. Our parent function, and we're going to start with our sine parent function. So we have an x, and then we have a y value, but we're going to call that x. Our x value will be our line. If we stretched out, if we snipped our circle and stretched it out, this would be our theta values, which would be our, in this case, our 0, our pi over 2, our pi, our 3 pi over 2, and our 2 pi. Okay, so that would be our x values, or our theta values, and y would be sine of x. And in a minute we could do a table with cosine x, and we'll do that. But right now we're going to talk about sine x. So our sine x value would be our y values. Notice what happens when we're at 0 radians, then our sine of x, or if x is 0, our sine of x would also be 0. When we're at pi over 2, our sine value would be 1. When we're at pi, our sine value would be 0. When we're at 3 pi over 2, our sine value would be at -1. And then when we get back to 2 pi, we're back to 0. Let's stretch this out on a graph and see what it looks like. I'm going to go down here and see if we can do this. So again, we're making our x-axis the rotation, or the radian measures, the x values of our graph. So we're going to make this pi over 2. We'll make this start at 0. We'll make this at pi. We'll make this 3 pi over 2. We'll make this 2 pi. We could also go the other direction on our graph, and this would be negative pi over 2 and negative pi. And we could do that, and we will do that on our graphs also. It goes in both directions, but I just want to kind of fill you in right now where we are. So, if we did that, excuse me, and we go off of our table, and we'll just make this mark up here 1, and this mark down here -1. What I like to do is since it looks like the highest part of our graph is at 1 and the lowest part of our graph is at -1, I'm going to make this little dashed line here. It helps us keep our graph a little bit straighter. I call this creating the highway. Okay, you have an axis here in the middle, right here. And you have these outside dotted lines. It kind of looks like if you're going on a highway, and the solid line separates the two sides of the road. Okay, so let's go ahead and go right off of our table. 0, at 0, we are at 0. At pi over 2, we move up to 1. At pi, we're back at 0. At 3 pi over 2, we're at -1. And at 2 pi, we're back to 0. Alright, so we have our lines, and we're going to make these curves just because it's like the curve of our circle. It's like we took our circle and we are now drawing it out straight on a line. So this would be what our basic sine parent function looks like. One thing I want you to note, we want to talk about our we want to talk about our domain and our range. And I also want you to notice that sine, something that's really important, that our sine graph always starts at the axis. It's always going to start at the axis. Not necessarily at 0, but it's going to start along the axis somewhere. It could move, it could shift left or right, therefore not starting, or we may not have a point at 0. It could shift over 1, but it would always start on the axis. And that's in comparison to a minute when we get to cosine graphs that start somewhere else always. Our domain, again, this graph, I've just done it from 0 to 2 pi, but we talked about up here on our unit circle that could just continue to go round and round, and we could also continue to go in a negative direction. So this graph would go left and right forever and ever and ever. So the domain would be negative, positive, infinity. The range values, our y values on this graph, would go up to 1 and down to -1, so from -1 to +1. And it's equal at that point, so there's our range. Something else I want to talk about. If we make one rotation of our circle, we call that one cycle or one period. And so one rotation of our circle gives us one full section of this graph. Now, we'll continue to make more rotations and have more of those, but our period, or our one cycle, this one cycle of this graph occurs in a distance of 2 pi, from 0 to 2 pi. So our period is 2 pi for the basic parent function. The other thing I want to talk about is the distance from the axis to the top of the curve and the distance from the axis to the bottom part of the curve. That distance is called amplitude. Amplitude. And in this parent graph, that amplitude is a distance of 1. Okay, those are some very basic things about our sine curve. All right, let's go on to a new page and look at our cosine curve. You may want to pause and make some notes first before we do that. Okay, let's continue on with our cosine graph. I'm not going to redo the circle, but we are going to do our table. Actually, I will do the circle, just the key points on our circle again. 0, pi over 2, pi, and 3 pi over 2, and 2 pi. Now, once we do this a couple of times, you won't need to do this anymore. Remember, our point here is 1, 0. Our point here is 0, 1. Our point here is -1, 0. And our point down here is 0, -1. And this time we're going to talk about cosine. So we're going to talk about the 1, the 0, the -1, and the 0 as we move around our circle. So let's create a table again. So we have our x values, or our theta values, and we have our cosine x values this time. So again, our radian measures, or our x values, are still 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those are just some key values. Those can change if our graph gets stretched or compressed, and we'll talk a little bit more about that, and we'll certainly practice a lot of that. At 0, our cosine value is 1. At pi over 2, 0. At pi, it is -1. At 3 pi over 2, back to 0. And at 2 pi, back to 1. So let's take a look at what that looks like on our graph. So again, I'm going to make my key values here at 0, pi over 2, pi, 3 pi over 2, 2 pi, and it would continue. And this way we have -pi over 2, -pi, and it would also continue. We're going to say this is 1, and we're going to say down here this is -1. I'm going to go in and build my little highway, especially if you don't have lined paper. It's really helpful. Kind of keeps your graphs straight. Alright, so now I have my highway. Now, at 0 this time, remember our cosine value is going to be at 1. And a while ago, remember I told you how sine started at the axis. I want you to write something over here in your notes. I want you to write that cosine always starts at the amplitude. Now, it can start at the top of the amplitude. It will in a parent function. If the graph's been reflected, then it would start at the bottom of the amplitude. So I'm just going to say that it always starts at the amplitude. All right, in this case, of course, at the top of the amplitude. At pi over 2, we are back to the axis. At pi, we're to the bottom of the amplitude. At 3 pi over 2, we're back at the axis, or 0. And at 2 pi, we're back at the top of the amplitude. So this graph looks like this if I draw it in. And if I were to shift it over pi over 2, then it would look just like the sine graph, okay? Because they are very related. I'm going to go ahead and continue. We went to the left, we'd be back here, and at here we'd be down here. So our graph would look like, oops. Sorry, make that curve very good. Our graph would look like that, and it would continue on. So again, we have a domain of negative to positive infinity. Again, we have a range running from -1 to +1. Again, we have a period. The graph occurs between 0 and 2 pi, and then it repeats itself. So the period is 2 pi. Everything happens between 0 and 2 pi. And again, the amplitude is that distance from the axis to the top of the amplitude, or the axis, and the bottom of the amplitude. And so our amplitude, I'll abbreviate that, is 1 in the parent function. Hey, both of these look a lot like just a basic higher degree polynomial function. It's a very curvy shaped graph. All right, we're going to talk about a couple of more things for tonight and identify the different parts of our function and what they mean in terms of shifting our graphs around. And I'm going to give you a suggested order into set up your graphs. And then tomorrow in class, you're going to practice some problems out of the book. Tomorrow night, I'm going to give you more examples similar to the ones we're going to practice in class tomorrow to give you a little more extension. And then on Wednesday, we'll have a worksheet. I will hand you a worksheet packet. I may even be able to do that tomorrow if it's printed, but if not, I'll give that to you on Wednesday, and we'll practice more cosine and sine graphs. Wednesday night, we'll talk about cosecant and secant, and practice on Thursday, and Thursday night we'll talk about cotan and tan, and we'll practice on Friday. And then we'll review all of that and practice extra on Monday, and the next Tuesday will be your next test. I have a calendar for you tomorrow and some notes to hand you as well. All right. I was saying all that, well, hopefully you're writing all of the information down. If you need to pause, go ahead and do that, and we can then continue with a little bit more explanation. All right, let's continue. I want to talk about these basic graphs. These basic sine and cosine parent functions will be shifted, reflected, stretched, compressed, much like, if I already said reflected, much like all the transformations we've done in the past. Let's look at that second form of the equation again and kind of recap our transformations. And then I have a suggested order. I'm also going to give you some handout notes on this tomorrow that'll explain also, but this will be a really good place to start when you look at your notes tomorrow to even maybe annotate them. All right, so that second form of the equation was y equaled a. That's an important value. Remember, we're talking about this is for sine or cosine graphs. And then we're going to have a bracket, and we're going to have b, and then we'll have x, and it's going to be plus or minus, meaning it's plus something or minus something. It's not both plus and minus. It's plus or minus c over b, and then I'll close the bracket, and then we have plus or minus d. So let's kind of identify these. All right, so let's identify A. A has to do with your vertical shift or change. Actually, not shift, but your vertical change. So it's stretching or compressing vertically. This is the same thing that we've had before. So your graph is stretching or compressing vertically. If it were negative, it would mean a reflection. And basically, this sets your amplitude. So the absolute value of whatever A is, that absolute value is your amplitude. Go Bearcats. All right. For B, let's take a look at the value of B. And B is something we factored out of the original equation. I think the ones in the handouts will all already be factored. I'm not sure about the ones in the book, so we really need to pay attention to that. You really want to put it in this form so that your transformations are easy. This will be your horizontal stretch or compression. So it's your horizontal stretch or compression. This will change the period of our graph. This will change what distance, listen to this carefully, this will change the distance that your curve will happen in. The curve will always be for sine here and go up and like this. And for cosine it will look like this. But it will happen either in a compressed amount of space or a stretched out amount of space, and that is called your period. So this B value determines your period. Your basic period is 2 pi. If B is anything besides 1, your period becomes 2 pi divided by B. So if the period is 1, it's just 2 pi divided by 1, and the period is 2 pi. But this is going to determine your period, the distance in which that curve, that full rotation occurs. If you think of one rotation around the circle, this is one period or one cycle. So the distance in which that cycle occurs. All right, we'll talk more about that. This is probably one of the most difficult parts of when of the graph is when you have a horizontal stretch or compression, and because we're dividing, it means it will happen opposite of what we think. Just like before, anything happening with our x value happen opposite of what we think. Same thing here with our plus or minus. If it's plus c over b, then we're going to go to the left. If it's minus c over b, we're going to go to the right, just like we always have with our transformations. So our c over b has to do with left and right shifts. It will happen in the direction that you don't expect. It's the opposite direction from what it looks like it should happen. And this is called your phase shift. Okay, this is your phase shift. This is your amplitude, your period, and your phase shift. And finally, we have our vertical shift. Remember, I changed that word on the first one. This was really your vertical change, your vertical stretch or compression, and it also has your reflection. And this is how much the axis, this will determine your axis. So your vertical shift determines your axis, how far up and how far down your axis will occur. All right, I'm going to have you probably pause and make sure you have all of these notes and just think about what I said. So maybe if you need to rewind and listen to what I described, if you've been writing, or if you've been listening, you want to pause now and write. Okay, and then I have one more thing, and then that'll be it for tonight. All right, the last thing I want to talk about tonight is the order that I would suggest for graphing. It's not the only way to graph, but it would be the order I would suggest for graphing, and it's a bit different than our other transformations. Before, we always did all the horizontal movement first, and then went back and did vertical movement. I really wouldn't do that this time. I would first start with building my highway, and in building my highway, the first thing I want to do would be set my axis. So I want to set the axis, which is your D value. The second thing I would want to do is I would want to finish building my highway out, those little dashed lines that you saw when we did the parent functions, and that would be setting my amplitude. So I want to set the amplitude. And remember, that is the absolute value of A. And I would do that with dashed lines. So here you set your axis. Here you have the axis and you set the amplitude. That would be your dash lines. 3, I would do the B and the C over B. So these are kind of two things that you do almost simultaneously. So this would be setting your period and your phase shift, because you won't have both always. If you have both, then you have to determine that your graph would traditionally start from one place to, what period it would start, from 0 to where. And then you would need to shift that graph left or right, and shift both the beginning and the end. Shift the 0 point, shift the 2 pi point, and then that way would give you your within the period that you need, or the beginning and the end of that period. It may not be from 0 to 2 pi. Your period may have changed. You kind of have to determine the period first and then move left or right. That's a little bit trickier. And then finally, you want to also note any reflections. So in a sine graph, in a sine graph, traditionally where you start at the axis, you would continue to start at the axis, but if it was reflected, you would go down instead of up first, and your function would look like this. In a cosine graph, traditionally, you start at the top of the amplitude. In a reflected cosine graph, so this would be a negative, you would start at the bottom of the amplitude and then go up, top of the amplitude, back down, and then back to the bottom of the amplitude. And your graph would look more like that. All right, I think that's it for tonight. Make sure you have really good notes. Again, I'm going to give you a handout tomorrow with some notes on it, but you're going to want to use these notes to annotate those, to add to them, to clarify. We're going to talk about clarifying anything you have tomorrow, and we're going to practice some problems out of the textbook tomorrow. And then tomorrow night I'll give you some additional examples, and you'll have some worksheet handouts on Wednesday to work on. All right, hope you had a great long weekend. Looking forward to a fabulous new semester, and I hope you have a good evening, Bearcats. Night.